welcome our speaker for today's lecture, Engineer Arthur Omar Mamoko.
Thank you very much, Doc King, for that wonderful introduction. Actually, I think Doc King is only 10 years or 20 years older than me. So today, why I need to ask this question before I'm going to start my introduction. Some of you may ask that why we need to have a temporary works procedure. Some may think that it's not needed because I think in the Philippines, it's not yet being practiced with that extendency, unlike other countries. So with that, before I make the introduction of my topic, let me share you a simple story with conversation with my dad, which is the late Major Mamoko. He's a professor, as what have introduced by Doc King. I asked him way back, I think 26 years ago, I asked him that I need to take the board exam. That was, I think, 1995. So he asked me why. Because my friends, I answered, because all of my classmates are already taking the board and they took it and they passed all. So I think I need to take na kasi I was behind one semester because of the job that I've been into. His job in Lake Lanao Environmental Studies. So he said, okay, you take your board exam. Yes, and I need to have a review. And then he pondered a little bit. And then he said to me, okay, but see to it that the boarding house that you are getting is very safe because I will be taking the review in Cagayan de Oro City. So he told me that. So I think at that time, he already have that sense of safety in his mind, because what we know in our industry today, the safety, the hierarchy of control is the first one is elimination. If you can eliminate as much as possible as hazard, all the hazards in the environment, then that is the most effective way in eliminating hazard. So he said to me, you need to get a place which is safe. There are no mga bugoy, kumbaga. So that in that sense, I remember that very moment, safety is the main concern of my father. So, and the rest is history. I passed the board exam. I took it once, and then here I am now. So that's a simple story that because of the introduction of Dr. King, the more I miss my father. He passed away last 2013. So now I need to start now the topic. So my question is why we need to have a temporary works procedure? So the British people, New Zealand, or the advanced countries like Australia, they have this already in place in the construction industry. The Bible of temporary works is the BS 5975. So let me show you my screen first. Just relax because we will be having some interactive part later on in the presentation. Can you see my screen, Ate Marcy? I hope you see my screen.
Okay.
Okay. So let me proceed. Now, that next slide, before I go to the third slide. Sorry, I have a difficult. I have a Wi-Fi glitches. Di mag-move yung picture. Anyway,
Okay.
that's the first. Anyway, that's the second slide. Those were the pictures of past accidents. Those pictures are taken at different locations. Like the one on top left is in Singapore, the Nicole Highway, where there is a geotechnical failure, like a sinkhole, and then all the whalers of the copper dam broke. And the next one on the right top is the Heathrow. Also, there's something, the failure of the slabs due to that container ban, stacking of container bans. And also, there's a plant here at the bottom left, also a collapse, very catastrophic. And also at the bottom right, it's in California. It's a pedestrian bridge. So I think a lot of cars being hit by that accident. So why we need to have a temporary works procedure? But I will go to the next slide. Slow. The British standard specifies the temporary works procedure is more about documentation, recording, and since it is a procedure, there is a process involved, the process of step-by-step permitting, step-by-step handling of information from conceptual design or from site request up to the final design. So, sorry, because the screen is lagging. I cannot move my slides.
Anong gagawin?
Okay. The next slides that we are seeing now, it's the CR4 project of NLEX. I think one of our client is within this webinar, and his name is Sir Nelson de los Reyes. It's one of the dynamic boss in our NLEX also in this implementation of this project. I know he has also some of his colleagues attending this seminar. So as you can see there are cranes. There is a curvilinear steel girder being in place. But apart from that, I am more interested about temporary works. You can see there the shoring towers, the lifting frames, shoring pads, concrete pads, and also there is a stringent safety and traffic management being imposed. You can see on the right side is the mobile crane. They are doing the tandem lift of that segment. So, by the way, this project is already almost done because the portion of that going on your screen is being constructed by the MCI. So we have that interfacing of that last part. And the two bridges on you can see on the left side, it's the CR1 and CR2. So for R10, it is now being open to the public. And one thing that why I share this picture is this project is a success. Why? Not because we hit the schedule, we hit everything, even the cost, we minimize the cost, but more importantly, this project has reached more than 10 million man-hours LTI free. Meaning to say, there is no lost time injury of this project. Kung meron man, if there are small injuries, maybe they can go back afterwards with medical treatment. So there is no LTI. That's the best thing that this project is, I should say, I'm proud of. So with that being said, because this portion of the project, as mentioned by Dr. King, we will be designing those shoring towers and the lifting procedures on the last fourth part of this series of webinar. So just let me continue to the next slide. So this new slide, as you can see, this is a simple temporary works using timber. Um, it has been hit by a flash flood recently. I think it's a month ago, wherein the district engineer is my colleague, my classmate, and he called me up and said, "Is there a chance that we could pour the concrete after this incident?" And I told him, "I think it's not safe to do that. I think you need to have a retrofitting or a strengthening of the shoring because it is being washed out. And then I think you have to address all the cross bracing because normally, as you can see there, all the shoring are vertical, less on the cross bracing. So all of those advices and suggestions he implemented on site. So now, as you can see on the right side, there are orange, that's the sketch from our conversation, our chat. So he implemented everything with double redundancy of the timber. And now they pour the concrete. And what is the good thing there is it was successfully concreted with safe, without any harm, without any failure. So the thing is, the temporary works there has been in place, although the schedule is so tight, but he is proud, and he is proud to share a lot of pictures that that project is being complete, almost complete now, and without any injury or fatality. Let me go on to the next slide. This is a simple temporary works. We're in the ramp. We are doing some strengthening on the ramp using geotextile, and then wrapping encapsulation geotextile just to strengthen the approach slab. And this is also in the project of NLEX segment 10. The after this one is the R10. So another slide is, as you can see, this is a copper dam. This copper dam is the biggest. As I go back to the slide, you can see there this column, this central column is very big. Okay. This one beside this steering tower, that's the one being supported, and that's the one here in this copper dam, this pile cap. So this copper dam is very large. That I think it's around 13 by 13 opening of excavation, and the depth is not too deep. It's around 3 meters, but the challenge there is the water table is so high, so a lot of pumping, dewatering is being involved. But we finished that copper dam without any injury. We successfully hit the target, and now the column is standing. This is another picture. It's too wide. The whalers are too big. The cross bracing, the struts too huge, and the sheet piles is I think it's type 3 sheet pile. Next one. Let me. By the way, the pictures that I'm showing you right now are the projects that I undertook with my team, the engineering team of my company. So this one, another temporary works were in the Botas Bridge. We do the piling, and then there is a river there. That platform, we design it to support that steel casing. And then we are using some tool like finite element analysis and so on. So again, it was a success. This one is a simple, typical rebar jig. So where the guys are making their rebar cutting and bending. This is the steel casing that I showed a while ago. This is the one being lifted. The next picture also is a simple pipe lifter of RCPC. We designed that pipe lifter steel 50 mm steel thick using finite element also, and again, it has been used in our company. It's very robust. Another picture of a simple rebar cage fix, wherein there are bracings inside to maintain its stability, and all of those lugs and the rings are being in place because that is too heavy. The rebars are, I think it's 38 millimeters diameter. So those are simple examples of temporary works. This one also is a standard scaffolding, wherein all the works of putting the ring or the ties of the board pile or the columns are being placed. So the guys there are having our own, the standard platform or scaffolding with all the rails, harness and everything, the PPEs. So those are the typical system that we had in constructing columns. The next slide. This one is the shoring tower of the one I'm shown to you earlier, the CR4 bridge, of which we designed it also. Design check only because the contractor provided this one and we check the design. And then again, the weight that it carries is around 200 tons, 150 to 200 tons capacity. So still, there are no accidents or any injuries with this one. There are no damage to properties. And this is very successful and very tested. In fact, we use it, I think, twice. So the next slide is some occupational statistics about construction mishaps for the last 8 years, starting from 2010 up to 2018. So here, as you can see, a lot of non-fatal incidents. Some are occupational fatalities also, but less. But I'm more concerned about the Philippine performance, which is at the bottom. The non-fatal is 417, and the fatal is 3.8. That is up until 2017, and I think there was an additional maybe in 2018 and 19, except those COVID fatalities is not a related constructional related fatalities. So this one, as you can see, the last part, the Malta at the bottom is 0. It's 0 fatality, 0 occupational fatality, and non-fatal, meaning I think no construction or no construction activities, or they implemented the best temporary works. I don't know. So it's just an statistics of why we really need to have a temporary works procedure in order for us to avoid and prevent fatalities in the future. Let me have some, the definition of the temporary works in British standard is more likely to be focused on the procedure. This one are just minimum guidelines, like it helped to ensure that the construction site is safe for both the workers and the public that may be coming into close contact with the site. So fencing, scaffolding, concrete shutter, and everything are examples of temporary works. Such a broad classification, it crosses over some regulations like Health and Safety at Work Act 1974, approved codes of practice and industry guidance, and construction design and management regulation 2015. As we go on to the next slide, looking at heights regulations, there are very established guidance in other countries. Unlike us, I think we are still on a work in progress. So there is a minimum standard for temporary works, which was published by the BS 5975. And this one we'll be talking right now, the BS 5975. This is to manage temporary works. However, this doesn't mean that a certain company cannot make his own temporary works procedure. They are free to do so as long as the minimum guidelines of the British standard they have to follow. So now number one, this slides is the definition from the BS 5975 about temporary works. It's supporting or protecting an existing structure. Wait, I need to go to my other laptop because the screen is covering my slides. Supporting or protecting an existing structure or permanent works during construction, modification, or demolition. Next slide. Securing a site or providing access to site or workplace on site or segregation of pedestrian and vehicles. I think, as you can see here, there are small items only. I think there is no challenge of concerning those ones. But as we go along, supporting or restraining plant, materials or equipment, as we go along, it became larger, including stability of segregation of pedestrian and vehicles. Next slide. It is a provision of earthworks or slopes to an excavation or supports to the side or roof of an excavation or supports or diversion to water course during construction operations. I think this is the last slide for that definition. Providing a safe platform for work activity on land or water. Actually, this definition is the latest revision of British Standard 2019. The one it preceded is the 2011, I think, which is not of this kind of definition. So providing measures to control noise, dust, debris, fume, air quality, groundwater, site discharge during construction demolition, providing protection and support to services, and facilitating testing. So a lot of testing, like the one being done by the PGA hammer, the testing, PBA test, and also maybe the non-destructive test, I think, is involved in this type. So here are examples of temporary works. I put some colors on it because so that we can, I think, have a distinction of each temporary works. Earthworks, trenches, excavations, temporary slopes and stockpiles, structure formworks, poles work, propping, facade retention, needling, shoring, edge protection, scaffolding, temporary bridges, site hoarding and signages, site fencing, copper dams, working platforms, etc. I think this is not limited to this definition, but still a lot of temporary works are not being listed here, I'm sure. Equipment foundations, tower crane bases, supports, anchors and ties for construction hoists and mast climbing work platforms, groundworks to provide stable, suitable locations for plant erection, mobile cranes and piling rigs. Those are simple examples. So now we are on the part of defining the key players or key personnels of temporary works procedure. Let me introduce to you the first actor. The first actor is the project director. In your company, we must have at least the project director or project manager. So this project director or manager, he has the overall responsibility for the implementation of this temporary works procedure. Unlike, I think, in the Middle East, if there are fatalities or mishaps, the project director will be the one to go first, to go to jail first. That's the severity there in Middle East. But here in us, in the Philippines, I think it needs to have some court proceedings or whatever. So the PD or PM must nominate the engineering manager, ensuring the engineering manager has the minimum required experience to satisfy the requirements and allocate suitable resource to the engineering manager to ensure an appropriate number of suitably experienced TWCs are appointed such that they are able to undertake their role in an efficient and objective manner. So I will be going through one by one with these key players because there is a need for us to understand their role because we cannot appreciate the procedure without even having the glimpse of how they do the rules. So the next one I'm going to show to you is the next player is the construction manager. The construction manager is responsible for the development of the CMS. The CMS is the construction method statement. It's the heart of the construction because everything there are being placed. Safety, risk assessment, inspection and test plans, temporary works, all working procedures, safety procedures like working at heights, working near waters, working I think in confined space, lockout, tag out, and everything. So it is being put in the CMS, and every individual who is being assigned with the role is to sign off in the CMS. The CM shall ensure that all staff and operatives clearly understand what is required of them and may require the TWC to explain details of the temporary works. Actually, the TWC, I will explain it on the next slides. This has the very important part of this procedure. The CM shall also appoint a RSP to oversee installation and dismantling of each temporary work scheme. So this RSP also will be explained on the latter part. So the next key personnel is the engineering manager. The engineering manager shall be experienced in the design and engineering of the temporary works to be used on the project and shall have a minimum of 10 years experience, relevant engineering and design. And he is mainly responsible for ensuring that there are an adequate number of appointed TWCs or temporary work coordinators and TWCMs, coordinator minors. And again, appointing the TWD and ICE. So those definitions, those abbreviations will be explained later on. Ensuring all have the required experience to satisfy the requirements. Implementing this procedure at a site level. Ensuring effective coordination between the design team, TWD, and the construction team. Okay, malapit na tayo. So we go on to the next slide. The next one, this is the heart of the procedure because this guy, I think he's younger than those previously being shown. This guy is the temporary works coordinator. Actually, this is my first function here when I went here in this project. Actually, I'm from Davao and we moved here last 2018. So I work as a TWC. So the function of TWC is very stringent and very crucial because he is the one to ensure that contractors' procedure to be control of temporary works are implemented on site. Kumbaga, he is the police on site. He can stop the work and he can allow the permit to go, permit to load and unload. He has the power to stop. So this is the kumbaga si Jack Bauer of 24 or siya yung si Merlin or si basta this guy has a big role here in this procedure. The key attributes of a competent TWC are number 1, relevant experience, formal TWC training, and professional qualifications. TWC should have the competence and authority to be effective. And one more thing, the basis of his inspection on site, the basis of his all of his decision is based only on safety. So meaning to say, he doesn't care about the cost or how it is being done as long as it's very safe and as long as it follows the procedure or the drawings, the approved specifications and everything. So that's the role of the TWC. So allow me to go to the next slide. The next slide, this is the one I mentioned earlier, the responsible site person. This guy is the one to initiate all the requests. He is the project engineer. So he will initiate and he will discuss it from the construction manager, what will be the next work to do, and he will capture all the temporary works involved. And after that, he will raise what we call a design request and you may have a nomenclature or design 1, D1, or TW1, or whatever, as long as it's the first step in having a permit, that design request. So this RSP shall be appointed by the construction manager. The TWC is appointed by the engineering manager. Responsible for initiating the temporary works design request, TW1, I said earlier. And number 3, responsible for raising temporary works design, change request, TW2, because there are designs to be changed. And number 4, responsible for the load unload, TW4. This is the bread and butter of those guys, because they wanted this TW4 so badly, because TW4 is the permit that they are allowed to, for example, to pour concrete, to install shoring, to remove shoring, to lift the girder. That's the very important permit on site, the TW4. So when the construction of the temporary works has been checked with certification TW3, this TW3 is certified by the ICE. The ICE I will explain on the next slide, and is complete and ready for loading or removal. So ibig sabihin, there is no such thing as kahit sino ang any guys who can dismantle or load, unless authorized. You are not authorized to dismantle. Even the RSP is not authorized to load or dismantle a certain temporary structure if there are no TW4 being signed off by the ICE, designer, TWC. So it's very important. Now the next slide, I added this one because it is although it's a small part of the procedure. He's a new guy, a newbie guy, but this guy is also functioning as a TWC, but more on minor works. Next. This is the temporary works designer, of which I am doing also right now in my company. The TWD shall be appointed by the PD or engineering manager with due consideration of the nature of the project or complexity of the temporary works. The role of the temporary works designer, TWD, is to prepare safe, ergonomic, economic, robust, and practical temporary works design schemes in accordance with the temporary works design request TW1. So kumbaga he will be the one to get all the information before he will do the design, like what is the load of the temporary works being considered, how big is the copper dam, how high is the shoring tower, how strong is the wind, or how deep is the water table. Everything, all of those information should be taken by the TWD, because one information being messed out, it will be a hazard to the design. The design will be unsafe. So the preparation of design calculations, drawings, and specifications should be undertaken with similar rigor to the procedures applied to the design of the permanent works. Ang ibig sabihin nito, kasi bago this is a new definition in the 2019. Wala to sa 2011. But this one, I think they put more emphasis also on the design, the robustness of the temporary works, because to the point that they associate it with the permanent works design. So that's what I understood with this line. Temporary works engineers include the manufacturers and suppliers of proprietary temporary works like shoring towers. There are proprietary provider here in our country. I think to name up the few, RMD, EFCO, Alcina, whatever. So they are the ones who give the design of their shoring towers and scaffoldings, etc. And those working in a contractor's temporary works department or office, temporary work designs are sometimes categorized to indicate the complexity, simplicity of the specific temporary work structure, and the potential risk. See below for an example. So maybe the example will be tackled later. Let me go on to the last guy, I think. This is the last guy, the last player of the procedure. the ICE. The ICE is the independent checking engineer. So normally in our project there in NLEX, R10 or segment 10, we employ the ICE. It's not an internal, but the ICE should be an independent checking engineer from one of the consultants in the Philippines. They are this guy is checking all the design of the TWD. So to ensure that the design is done in the right and safe manner with all the codes and standards being employed, he will check everything, even spelling, the spelling of the design brief, he will check. So that's the stringency of the ICE. The ICE is the check and balance of the design on site. So it's very important because if there are being missed out by the TWD, there are items, then this guy also can counter check. So that's the role of the ICE. Any design modification issued in response to a temporary works design change request, TW2, for works that have been checked by the ICE shall also be reviewed and endorsed by the ICE. So this guy is also the one to certify on what we call the TW3, the design certificate. If there are no certification coming from this guy, then we cannot issue a drawing for construction. So his role is very important. He is the whole point of this procedure. So go on to the next slide. I'll just show you one example on why when we lift that segment in the one I showed to you, the second slide, the steel girder, curvilinear box girder. Before we lift that one, we have some studies. We took the heaviest segment. This is to appreciate why we are doing this temporary works, because when lifting this one, there are a lot of temporary works being involved, like lifting gears, shoring towers, lifting lugs, slings, and everything. So we need to know what is the heaviest load that we need to lift using crane. So as you can see, 97.18 tons, you need to have a dynamic factor of 20% just to increase the safety during lifting. Because we cannot, because in the design, it's all assumptions. We cannot predict exactly 100% what is the outcome. We are more on the reasonable and safety side by using code-based design. Some may do displacement-based design, some may do performance-based design. But this one, we are using the direct, I think this direct analysis on lifting using a simple factor of safety of 20%. So go to the next slide, just to analyze simply to get the load requirement in terms of uniform dead load of the segment of the beam, the girder. And then you can analyze using different softwares. Here I'm using STAAD Pro. So STAAD give us the maximum shear and maximum moment and deflection as well. And with that being said, the segment is safe to be lifted up because, as you can see, there are a lot of safety factor, like the deflection is not more than the allowables as per AS2 allowable recommendation, and also the utilization of the stresses is too low because normally it's designed for permanent works. The only thing that very critical during lifting is the local check, because the global check, global design, we know that it's safe. The local check, I mean is that we are checking on the particular portion of the structure, whether it is overstressed or not. So like this one. This one, we check the lifting lug. The lifting lug is designed to have a capacity of 55 tons, as you can see there. I will, I think I cannot magnify this one, but anyway, that lifting lug, we analyze using also finite element analysis and then using STAAD Pro. So as you can see the color, as you go down, the red ones are the most stressed ones, because this one is, I think we are just using the Boone-Miss criterion. The Boone-Miss criterion in finite element is more about the distortion energy. The more it close to the elastic limit, yield strength, I mean, the more it closes to the yield strength. For example, your steel is 36 KSI or 250 megapascal. And then you have a stress bone miss of around 53. You reduce that 250 to around 0.6, maybe it becomes 150. And the requirement, the demand is 56 and the capacity is 150. So you are safe. Demand versus capacity, and then you have the utilization ratio. So as we go, as you can see, there are 27.2 utilization, around 62.8 safety factor of safety, and then 86 utilization. This is close to 100. So it's I think it's not yet overstressed, but still safe. And the bottom is the 19.33 and so on. So what is the beauty in doing temporary works if you have the tool? If you have the software or if you have some program of your own, you can use that one just to validate or just to have a clear prediction of the behavior of the stresses of a certain structure. In this case, we are looking at local checking exactly on the shape, the exact shape of the lifting log we modeled using finite element. Now we go on to the next slide. Again, there are the stress utilization also being satisfied. And here is the erection plan. As you can see, there are footprints, red footprints. Those are the shoring tower footprints. So actually, by the way, the shoring tower is the heart of the erection because it's the one supports everything, the weight of the girder, and until it becomes permanent. So diaphragm fixing and everything, the shoring tower is still there. Next, it's just a simple representation of a crane lifting that particular steel girder. It belongs to the mobile and plant department. It's not more about temporary works. The only thing the temporary works involved in here in this diagram is the lifting frame. The lifting frame at the bottom left, it's the temporary, it's the one who we analyze and design. But the rest, the crane, the lifting, it's more about the plant. So the crane supplier, the crane supplier will be the one to specify what is the requirement or what's the radius capacity of that boom, and then and so forth and so on. So the next slide, again, it's the now as you can see there are those are traffic management also, because not only temporary works we are dealing with, those arrows are flow of traffics. So very important, because why? Because traffic is also a hazard. It's a killing, it's a class 1 risk also. It will kill. So as you can see, the direction, traffic management is so vital also in the construction industry. Next, here another thing is I showed this one because so that we can appreciate what is why we really need to analyze the lifting process. As you can see that the basic wind load formula, I modeled this one using again STAAD Pro, and then the crane, the weight of the crane, everything, the information, we modeled that one, and then put some counterweight, the same as the counterweight on the brochure. And then we lift that particular segment, and then we analyze it when there is a strong wind acting. So we go to the next slide. There are code requirements about the wind, like the velocity, minimum velocity, wind speed, and everything. And then here I'm taking the code, which is the American code, using the ASCII 7, and some for temporary works using the ASCII-37. And then this one, the one on the right, are also from that code, and this is embedded in our National Structural Code of the Philippines 2015. So as you can see there, everything is in place. We have the basic minimum load requirement to find the velocity and the pressure of that particular lifting using that crane. So the next slide, we were able to arrive at a particular wind force pressure, 89, and with a particular velocity minimum of 13.8 and 49.68 maximum. So as you can see there, we're just using, this is a code-based calculation. So the aim here is that we need to know what is the minimum wind requirement the moment that we need to stop the operation of the crane. So if the strong wind will happen at this particular velocity, we will stop right away the operation of lifting. So the next slide tells us about 1.42 kPa. We arrived at one using those code and reduction of temporary works, which is, as you can see, there 58% reduction because it's only exposed around 1 month to 2 months. So there are also reduction depending on the exposure of the temporary works. Next is this one. We modeled and analyzed using the STAAD Pro, and then the analysis tells us that the max nodal displacement would be around 256 millimeter for that boom on top, and the velocity is 13.8, and the 258 is greater than 254 mm just for limit state checking. We are here in the design, we are using the serviceability limit state 1 design for this crane, just to check that there are no distortion of the crane or whatever, like excessive deflection, etc. Next, you can see here with that result, using that analysis as per ASI 7 2010 with the load case 1 and 2, no load and with load, we arrive at the conclusion that velocity 13.8 meter per second or 49.68 kilometers per hour or up to 15 meter per second, crane has to be boomed down because it will give us a pressure of around 120 to 130 Pascal. So those are the working wind load limits that we have using that particular analysis procedure. So with that, you can now tell the people on site that with this velocity, you stop working or you boom down the crane. That's very important, especially also all those tower cranes. Tower cranes are very high. It will reach up to 50 to 60 meter high. And it's very robust because it is founded by a very big foundation pad. But still, tower crane is not exempt by this analysis. It should be analyzed also using this wind analysis to avoid mishaps. I just show this one because this is the real scenario when we lifted the first segment. The one we put the other side, the first pier, and then the temporary work, the temporary tower beneath on the middle of the two existing lower bridge. So that two steel girder is being represented in this 3D model is the one we really did on site without any injury, with a success, and with a less cost, and with on time. So again, this next slide is also another tower, the one I've shown to you a while ago. That this tower, the color brown, is the one we analyze also using this one. So again, we need to have all the loads, the permanent and the temporary loads, self weights, and then we will add some superimposed loads like winds and whatever additional loads, seismic also. So the question is, are we going to design this shoring tower using the code for permanent works, like using the 260 kph velocity of wind that had been reflected in SCP? That's the question. The answer is no, because this is temporary works. We need to reduce this one. We need to have some reduction factor using the ASI-37. It will be reduced around 0.6 or 0.58 with this type of exposure, maybe 2 to 3 months time. So with that one, we can still have it say it's safe and also economical. Because if we design every temporary works using the permanent works code, then it's not practical and it's not engineering because it's too robust and it's for permanent work only. So that's the reason why there is a code being established also for temporary works, especially the ASI-37. This one is a representation also the side view of the lifting process, wherein it's very important to know the reaction of the two girder being lifted and being put on the shearing tower. As you can see there on the left side, the 90.99 tons is the load expected on that shoring tower. And then as we go along, it will be spliced. And if those splice being connected right away, these two splices here, the middle part, then if that will be fully spliced, the load path will change. So I think it will experience more load than this simply supported state, because it was already on the continuous state. So the load path will change. So again, we need to reanalyze, run again the computer, and then it will tell us another reaction. So those are the process in designing. But we are not yet in the safety in design. We are just this is just what we are doing in our project. So it's very nice. It's very good to have these exercises in every project, especially for those heavy or category A risk, category A projects of temporary works. So next, this is the one I've shown to you in the first part. So you can see there the shoring tower, the crane, the tandem crane. We have the scaffolds, we have the lifting frames, lugs, everything, safety nets, and we also have this as we go closer. As you go in the middle, you can see there a scaffold, a working platform hanging. It's for the diaphragm works. So everything being in place, the procedure is being in place. We put some railings, lifelines. All the guys are wearing harness and everything. So you monitor the weather condition and everything. So this procedure, this success of this project is mean more of the temporary works aspect, because the success of the erection is not on the design or the consultant, because they don't care about how you do it, how you erect. They care about their design. They don't care about how you erect that one. You have to splice here, you have to put shoring tower here, but they will also approve your scheme because maybe it will be detrimental to their permanent design. So, but one good thing, one good news now is the British standard 5975, the code incorporates already now the 2019 edition, the version of 2019 incorporate now that all designers and consultants, they need to include in their design the temporary works or condition or the consideration of temporary works. So it will be embedded in their design. So lifting sequences, pouring sequences and everything, it will be embedded in the design also. So I think as the code is being revised from time to time, then there will be also an update of good and improvement from the previous version. So now the permanent designer and the temporary works designer, although they are not the same, but they have that clearly defined interface. The clearly defined interface of the temporary works and permanent work designer is that during the permanent works that will come in on the stage, they will see to it that the temporary shoring, like for example, will be removed right away. No more staying too long on the site, like you leave that one for how many weeks or so. So because that's now the responsibility of the permanent works designer. Okay, nandiyan pa tayo. So let me just see this. These are risk categories. A lot of this, as you can read this one, 20-meter high pulse work. You can categorize it at A. Geotechnical, the depth of excavation, A, if too deep, and so forth and so on. I'll just go through with this one because we have some other slides to be emphasized. So risk category B, medium size, 10 to 20 meter high, pulse work, Ground support schemes 2 to 4.5 meter deep, it is categorized as B, and so forth and so on. Lifting and falling objects, 5 to 25 tons. If you are going to lift the girder and the weight of the girder is 25 tons, still you are in the boundary of category B. The next one is the smallest category, the lightest category, which is category C. So usually category C doesn't need sometimes a TWD to design. The TWC or competent site engineer can design that one, like hoardings, fences less than 3 meters, and open cut excavation 1.2 to 4.5, and so forth and so on. And then temporary lifting and hoisting systems less than 5 tons. So medyo kayang-kaya lang. So these are the 3 categories that we are dealing with in this procedure. Here's an example of a permit. This permit TW1 is the permit to design, request to design. This design request form shall be filled up by the RSP and then submitted to the TWC, and then the TWC will get all the data, and then he will forward it to the engineering manager, and the engineering manager will validate, they will discuss, and then if it's okay, he will sign and give it back to TWC, and then the TWC will give it to the designer. So the TWD will design as long as all the informations are there. So after the design, if it's okay na, he will forward it to the ICE, the one I mentioned a while ago, the ICE, the independent checking engineer. So we go to the next slide, the TW2, this is a design request. For example, there is no such thing as this perfect design. Let me ask you in your mind, is there a such thing as job without temporary works or project without temporary works? That's a good question that I want to throw it to you right now. Is there a project that doesn't involve temporary works? Here, in this case, the TW2 is a design request, meaning there is a change of design. There are a lot of reasons. Maybe on the first assessment, there is a change in site condition, or there's a change in requirement from the client that you need to have an increase of loading, so we redesign this one. The client will tell us that we need this one to be this depth, this big. So from the first agreement, it's lighter, but now you need to have this double in terms of weight. So there is a design change. So design change also will be passed through the TWC. TWC will check and everything, and then he will give it to the TWD, and TWD will design. If it's an increase in design, increasing the design sizes of the section, he will design. And then why here, as you can see in the bottom, there is a commercial manager and project director line. They will sign this one. Why? Because this TW2 involves cost. So those guys are not responsible for the cost. The cost is responsibility of the owner or the commercial manager or the project director. So they need to sign off this one, the TW2. Next, this is the TW3, the one I mentioned, which is the certification from the ICE. So if the design is okay, the ICE found no error or it's okay for release, then he will certify this form, the TWC form. Then he will give it back to the TWC, and the TWC guy will give it to the RSP. The RSP now will have his request for loading because it is already being certified. Approved drawings are being issued on site and specifications and so forth and so on. The last one, this is the most important part of the permit. The one we need badly is the TW4. The TW4 is the one that is the permit to load and strike. So if the contractor wants to pour concrete tonight at 10 p.m. and then there are no approval yet with these signatories like TWC, and I think the engineering manager is not involved here, but TWC is the main key here and signed by the responsible site person. If the TWC is not satisfied with the work, he will not sign this one. So that's the problem. So these guys are very this is they wanted this so badly that they want it to be released right away. So if everything is okay, then that's the time the TWC will issue the sign of TW4, and then that's the time the site people will remove or load or pour concrete or lift or whatever, strike or unload or loading. So this is the importance of those 4 permits: the TW1, TW2, TW3, and TW4. So let me go to this. I make this process with a picture because uh, so that we can appreciate and have a glimpse of what is really the procedure is cycle is all about. The first one, the construction manager, for example, we are going to lift that segment of the steel girder. He will tell the responsible site person that you go there, make the design request, but see to it that all the temporary works are being captured, all the assessments, risk assessment, job hazard analysis, and so forth and so on. So the RSP will capture everything, and then he will give the design request, the TW1 to the TWC, and the TWC will give it to TWD. Then the TWD, if it's complete in information, he will do the design. And then after designing, he will give it to the engineering manager. The engineering manager will sign if it's okay. And after that, he will give it, before giving back to the TWC, he will still give it to the independent checking engineer, the ICE. And the ICE will certify. And then if it is certified, he will give it back, because as you can see on the title of the slide, TW1 and TW3, the request and the certification. So he will give it back to the TWCM or TWC, and then these two guys, either these two, will give it back to the RSP for issued for construction. Meaning the design is okay, the drawing is ready, being signed off and everything. So now the guy is about to make the TW4. So when making the TW4 permit, there are 3 players already only involved. First, the RSP, second, the TWC, and then the ICE. So you have this TW4 permit, the RSP will give it to the TWC and check it, and everything is okay. He will give it back to the ICE. Maybe the TWD will also be involved, but not always. But he will give it to the ICE. The ICE will certify, and then will release. He will release the TW4, and then the guy, the RSP, will have this big smile because he will do the loading and striking on site. Okay. Next, this is the last portion, which is the TW2. This is a design request. So if you have the design change, same process. The only difference is here is a guy that the project director is involved now, the commercial manager, because it is, as I have said, it involves cost. So it will go back to the RSP, and the design is changed, and then still they will make another TW4 and then issue the permit for TW4 to strike. So it's the same process. The cyclic process of this procedure is, you can familiarize this one because this is the heart of this procedure. So these are the key personnel. Okay, so this picture, I included this one because on the left side, there's a guy using this ladder, simple ladder. And on the right side, there is a complex copper dam. So with this, you can classify this very low, medium, and high risk. So the guy is going down on that ladder, on that stair is that it's considered to be very low. But on the right side, it could be considered as high or medium because it depends on the size of the copper dam, the complexity of the design, and the number of hazards or risk involved. So that's the classification in terms of class implementation. Okay. Before we go to the part 2, so now I think if you have some questions, you can throw your questions right now. We are now on the question and answer portion.
There is one question, Art, from Bashim Hajinor.
Yes, po.
How is TWC different from the role of the safety officer or safety engineer of the project?
It's a good question, Doc King. So I hope I can answer that one. But one thing I can distinguish the difference of the two is that not all safety officers are engineers, but TWC has a minimum requirement of 7 years experience in the design and construction. So you can be a safety officer and yet and still not an engineer. But if you apply for a position of a TWC, be sure that you know the principles, you have enough experience of the design and site supervision. I didn't say that safety officers don't have the experience, but in that requirement, you can be a safety officer even if you are not an engineer. That's the difference. I hope it answers the question.
So, Mr. Bashim Hajinor, do you have a follow-up question to that one, or that answers the question?
You can raise more questions because we have this. We need to have a very interactive one. I hope some of the guys can raise questions, and as much as possible, I will try the best I can to answer as many as I can.
For your information, guys, the participants, like if you have a question, just use the question and answer portion of the Zoom tool so that we can see it. I can see that there were some chats earlier, and there was a question in the chat from Hanford. May we request for a soft copy of the presentation?
Of course.
Is that something that you will provide?
Of course, I will give it to the moderator, the sponsor, which is Ma'am Marcy and his office, and they will be the one to give you the soft copy of that one.
Okay,
no problem.
Good. So fire it away if you have questions, guys. While our speaker is having a little break, just waiting for your questions. So this is the time to ask your questions for the first segment.
Actually, I'm not an expert here, but what we have experienced on our project, which has, I should say, a tremendous success. Yes, I can share this part of temporary works, but as we know, temporary works here in the Philippines is that it's still a work in progress. And I think maybe in our authority, or maybe the ASEP or DPWH or whatever organization will have it in place in the near future.
There's a question, Giorgio de la Cruz. Would you like to ask a question?
Yes, Giorgio.
So a question from Giorgio de la Cruz. What software does your company use for the 3D model?
Okay. We are using different softwares for 3D modeling. If the model is so complex, we are using first we do it using SketchUp, and then we will use this is what we call that very beam modeler. I forgot the name that I will tell you later on. But normally we are doing it using SketchUp. The one I presented to you, SketchUp. And those 3D analysis are using STAAD software. So SketchUp model, and then I think he developed it using Autodesk, still in AutoCAD environment. But they have that advanced software, which is it's not Lumion, but it's similar function for civil engineering and infrastructure, because Lumion more on architectural.
So the question from Jason Mamano, I think it's a follow-up to that one. Is it Revit?
Yeah. No, Revit, we use also Revit, but not Revit. I wait, because I will search right away. It's a very good software because it's more about for 3D presentation, and I am not the one using it. That's why I don't really wait. I can't remember. It's more still on the BIM. Although Revit you can use, because the good thing about Revit is it's TAAD compatible. No, I can find the name. I forgot the name. It's very good software. Sorry, I forgot the name.
So another question from we have Mazkar Hamsiraji. Good afternoon, Sri. Sir, being TWC, is it required to have a high credentials in safety? Like you need to be a SO2, SO3, or SO4?
For TWC, high credentials in safety will be of great help. But as I have said, this is this context about temporary works procedure is more. It's different because it's more about the procedure of more on the design and the process. But if you are a safety practitioner, like you have those post-boss training, you have the edge. But as I have said, this is a different world because in this case, I think if you want to become a TWC, an effective TWC or qualified, you need to have at least basic knowledge of design and construction. That's the two key attributes to be a good TWC.
So it looks like we have more questions coming here. So we're probably going to hurry a little bit. So there's from Net Balbiruna. Hi, Net. Thank you for the presentation. What are the key takeaways that you would like to provide to the attendees to be mindful of for? What are the key takeaways that you would like to provide to the attendees to be mindful of? Sorry,
Well,
it's 2 o'clock in Panama, so 3 o'clock.
Yeah. What do you mean by takeaway? If you have that, what type of learning or whatever? Because can you rephrase
kind
the
of
question?
like lessons learned or something.
The lessons learned, because that question will fall on the next part now, but it's more about on safety in the design, because the lessons learned is more about reporting the past happenings, and then you make it to improve on the next one. So lessons learned will give us the benchmark on how to improve the next project, and applying those good and eliminating those bad ones. So lessons learned is the basic takeaway also in this presentation, because we have that actual lesson learned here. Normally those small failures, because construction is not perfect. We are not perfect. We are not perfect, and everything, the TWC, the engineering and everything are not perfect, because it's all human. And I believe that the mishaps or accidents caused by any industry is 99% human error and 1% other. Why? Because they said 50% equipment error. No, I don't believe that one, because you can have a preventive maintenance of equipment. You can check everything. It's up to you to control. And one example is when Jeff Bezos go to space, I think 2 weeks ago. I think the one he ride, the spacecraft he ride, is that he rode that one is the extension checking is there. All the controls are there. They don't want to have the Columbia happen again, the Columbia disaster, the spacecraft, shuttle, the Challenger, and everything. So it's more about human error. Human error is the main key. Like one pilot will let the plane dive, and then nobody can save their lives because he's the only one in the cockpit. So some regulations, they will change it to 2 person inside the cockpit and so forth. So it's more about human error, I believe.
Okay. So another question, thank you for a very informative presentation. Is British standard, is it BS 5975 widely accepted in the Philippines?
The BS 5975, it depends on the company because it's not sad to say. Uh, I would answer that why I am the one being invited with this webinar, maybe not because that Ate Marcy is my friend, and not only that one, because of this topic, temporary works. My company is the only foreign company implementing this procedure here in our country. So I think that's the reason behind that. If you want to ask that if BS standard is widely accepted, for me, why not accept BS standard? They are the best. They are one of the best people. I don't know about the regulation here, but it will be, it will pass through like the deliberation in the ASEP or whatever, in the DPWH and everything, the National Building Code team. So I think it's not. It would be as long as it's good. It's more on about safety of the public. That's what we are using, like the ASI, the ECI, the EIEC. We are still using that American code. And why not use BS code if it's appropriate to use?
Okay, so there are other questions, but we will read the last questions right now. There are more, but in the interest of time, I was advised that, you know, for time constraints, we'll just have one more question here. So one here is from John Paul Pangan. In terms of safety, who will be most responsible if something wrong gonna happen?
Okay, that's a very, very nice question. I waited for that question in terms of safety. In construction, if the design fails, the one responsible is the designer and the engineering manager. Even if he said that you are the one designing and I'm the manager, you'll be the one to go to jail or you'll be the one being punished or whatever. But as long as the engineering manager has the authority and the responsibility to have the design in the right, all error-free and could be best suited on site. While if the construction fails, like there are collapse caused by mishandling or poor workmanship, then the construction manager will answer that one. But as a whole, even if the construction manager and or the engineering manager has their different responsibilities and to answer those mishaps, still the company that they are involved to will be the one to have to lose its reputation in the construction industry, especially if it's LTI or fatality. So if you are the designer, you will be the one responsible for the design, including your manager. And if you are the construction manager or the site engineer, if you do it the wrong way, because there will be a process of investigation, the first investigation will come out in the design, and after the design has complied everything, it will go down to the construction side. And if the construction side has done everything and okay, it will also go down to the QE and QC department. And lastly, to safety, because safety normally is independent. So that's that's the answer of that question.
Okay. Thank you very much for your question, guys. So I think what we'll do is we'll, at the end, we'll advise how you could, some of those questions that were sent that were not addressed yet, we're probably gonna give you a mechanism on how to send those questions for answer later by the speaker. So what do you want to do now, Arthur? Would you like to continue with the next segment?
Yeah, I will continue with a short one. The short second part
Okay.
is a very short one. So
Go
I need to
ahead.
continue this one because it's very important. Okay. Can you see the part 2 on the screen?
Not yet.
Not yet. Wait. That's a problem with me in using Zoom because I'm used to MS Teams. Okay. Okay. Now we are on the part 2 of our webinar. The small portion of this webinar, the continuation of the introduction part. Now this is called safety in design. Wait, they're a little bit lagging on the slide. Okay. As you can see on the screen, there is the hierarchy of control, the one I've shared in my introduction. The elimination is the most effective one. The next one is the substitution. The third one is isolation, engineering, and the fourth one. Second to the last, the administrative controls. And the last but not the least, I think they said it's the least, but it's the last line of defense, which is the PPE. Now, for example, you build, you erect a bridge on the river, and then you need to put temporary works like shoring on the river. Is elimination of shoring tower possible? You will analyze, you will assess that one. Is it possible to eliminate that putting the shoring tower on the river because it's very difficult? If not, then you cannot eliminate that one. You have to substitute. What substitution? I will not use it to go to the bottom of the riverbed, but instead I will use pontoon or barge, put the tower on the barge and everything or whatever, just to platform. So that's a form of substitution. Isolation, if cannot be substituted, it could be isolated. So normally, as we go down, the effectivity will become less, and then the isolation is more about isolate people from the hazard. Like when you go to that path, there's a dog waiting for you, but the dog, you have to, either the dog will be isolated or he will be inside the cage, or you will avoid that dog. So that's one way of this a hierarchy of control, isolation. But the fourth one is the engineering controls. So engineering controls is normally found in the manufacturing industry, and some are in like also in construction. Like you will be painting, you will be painting on the silo wall. So normally you will be painting a silo wall. You will be on the gondola or whatever elevated platform. You cannot eliminate, you cannot isolate, but you can put engineering controls. Engineering controls like you put some fall arrest or harness or climbing platform or monkey ladder or everything that make it useful, gondola. So those are engineering controls. And also some, kumbaga, there will be a capture. But if you go down, you fall, then you will just bounce back. So those are engineering controls. The next one, the administrative controls, is more about change the way people work. So it's more about documentation, like putting signage, like no entry. You put some safe working load on the platforms. Those are administrative controls. And then you have to train the people not to do this one, not to use cell phones while driving. Those are administrative controls being implemented on a certain organization. And the last one, the red one, the PPE, is the last line of defense. So it's basically the requirement on site. You have to wear masks, gloves, hard hats, safety shoes, goggles, and so forth and so on. So those are PPE. So the hierarchy of control is will come in a holistic view, because you cannot if you cannot use the other one, you can use the as you go down, then you only have the last resort, which is the PPE. So I think after the PPE, kung hindi ka mag PPE, then no more chance of ano na lang, luck or sprayer ka na lang, kasi if you pray, I believe that prayer also is the key to be safe on site. This one, as you can see on the screen, this is a risk assessment matrix. So catastrophe, in terms of fatality, there are catastrophic, moderate, high, critical. So you can use this one matrix also in temporary work setting. In temporary work setting, you can use this matrix to analyze or assess that, for example, you are changing the light in your room. You will need to go for a frame or ladder or everything, or elevated chair like that. What is the risk? So if you fall down, then it's low risk. If you have some unbalance or imbalance, then you will go fall down. It's a low risk because it's not a high. it depends on how we assess. In temporary works, it's the same way. We can apply this risk matrix. Now, we are here. Who is the designer? A designer is anyone who specifies or alters a design, a particular method of work, or a particular material. So, halimbawa, we design and then the owner will tell us that you change this one. He is now the designer because he will not listen to you. He will insist his section that you use this one. So he is the one responsible now, not the designer. So it should be clear the responsibility of the design. The one who alters is also the designer. So the owner will be the designer if he insists on his he wanted to use to change the section, more economical section, but critical or more hazardous in terms of capacity. So anyone specifying or designing how demolition or dismantling work is to be carried out, he is also a designer. Next, because of the onus is not just on designers, it is on any party who has an influence on design. For example, if the engineering design manager specifies or alters materials, layouts, work methodologies, they have a duty of care obligation to ensure safety in design. Then he is also responsible, and he is the designer, that manager. So these are just these are just benefits of safety in design. Safety in design are significant reduction, improvement in the health, reductions in damage to property, elimination of potential hazards. So you might ask, can you give us example of safety in design? So I will give you example. This one, as you can see on the screen, if you design a window, doing the window swing in would be safer than making the window swing out. Because, for example, this lady is cleaning the window. It's safe to have it swing in because he will not go his body outside the window. So it's a form of safety in design. Another one, the bottom left, is this is a folded light. So they will change the light, any replacement of the bulb without doing it at heights. So it's a safety in design. Another thing on top, left top, is the putting the air conditioner condensers or at ground level. So it would be safer to you to have that one than putting it on top or hanging it on in elevated position. So one also on the right, design safe access methods to service areas such as roofs. So those are very simple example of safety in design. These are more about duty to develop a design that is incorporates safety principles. I will not tackle that one because I will give this copy to you. So these are just abbreviations and definitions. So these are just self-explanatory. The risk category is here. The risk matrix is here. Category A being already explained a while in the earlier part. So this is more about self-explanatory. So that ends the safety and design portion. It's just an introduction of that portion because so that we will have an appreciation of why we do it. We design it using safety in mind. So if you have some question, still we can entertain me 3 questions before we go to the next part. I have a video. I will try to share the video. This one. I hope this will work because the video is computer is not too fast. It's a lag. So I think to share this video. Cannot find the so if you have questions you can type while I'm finding the video here.
So there are no new questions other than the other three questions that were not addressed yet. So would you like to try some of them?
Okay.
Let me check. I'm looking at some of the interesting ones here. So from Rudolph Habuli, is there any instances that the TWD overlook any deviations applicable in the design of temporary works? If it does, what corrective action may apply?
Since I thought earlier I've discussed about in terms of responsibility, and since we are human, the TWD is not perfect. There is also instances that he will overlook in getting all the information in order to make a safe design. So the key there is, if the TWD has his error or mistake in getting all those information, still we have the last line of defense, which is the ICE. He will
Closing
check.
remarks na agad ha.
He will check that one. So
Ano na lang after the closing remarks.
we have a check and balance.
Sorry.
That's the answer. The TWD has. There are times that the TWD will not get all the information and will not get the exact design. So they will discuss again to the TW at the RSP, and then they will sit down and have a meeting, a regular meeting of how they will do it the right way. So it's a process always as we go with this procedure. So I hope it answers the question.
So are you ready to do the video, or are you ready for another question?
I'm please
So he said it
have
answers
the
his question.
yeah. I found the video now, but I'm opening it. It's very slow. Wait, I think almost. I think there is impact of using this large webinar. Maybe it's very slow. I'm using Teams. It's faster than Zoom.
Mhm.
So the video is not opening, but it's more about. I really wanted to show that one because it's the success. I think it will not. We will just give. I think we will just give the video so that they can see what is really happening on that erection and the finished product of that erection. They will appreciate
Mhm.
the finished product. So I think we'll just give it to the participant, the one who wanna ask the video.
Okay. So do you have any more presentation or other than the video?
Actually, the I don't have any more presentation because the next presentation I have is more about technical on how to design. The one you have
Mhm.
mentioned, the next part, it's
Yeah.
categorized in three portions. So I think I'm good with all the introduction of the temporary works and the safety and design. So it's just
Yeah.
more about, yeah, I think,
So there's one question about safety. So this is
yes.
the only question about safety. So it's from Net Balberona. Is there possibility of including safety in design workshops involving relevant stakeholders in the process?
Yes, there is a possibility because actually the relevant stakeholders are also the one dictating the cost. So as I have said, clients, whatever stakeholders like permitting, right of way acquisitions and everything. When during the design stage, the preliminary conceptual design stage, they need to be involved, sit down and meet so that they will have their input, and then there will be no rework or back job. So everything, it's better to include or involve the stakeholders or the client and so forth during the conceptual stage. That I hope it answers your question.